Ever feel like we're just skimming the surface?
Mm-hmm.
Well, get ready to dive deep because today we're exploring a world that's right under our noses, or should I say, our boats,
Our boats. I like
the
that.
seabed. It's amazing how much is going on down there.
Oh, absolutely. It's a whole hidden landscape. I mean, we're really just beginning to scratch the surface, to understand it.
And the coolest part, so we've got like the ultimate guide for this deep dive, Wikipedia, that seabed page.
Oh,
It is jam-packed with the most fascinating details.
jam-packed is an understatement, maybe.
So, are you ready to uncover what lies beneath?
Absolutely. Let's dive in.
Okay, so when we say seabed, we're talking about the entire ocean floor, right? Like from the edges of the continents all the way down to the deepest, darkest trenches.
That's right, the whole shebang.
But it's not just like this flat, expanse, is it?
No, not at all. It's got its own incredible geography, just as diverse as what we see on land. You've got mountains, valleys, plains, the whole 9 yards.
Wait, underwater mountains? Are you serious?
Oh yeah, totally serious. They're called mid-ocean ridges, and they're formed by seafloor spreading, which is where the Earth's tectonic plates, those massive slabs of the Earth's crust, they're slowly moving apart.
Okay, quick geology refresher. Tectonic plates. Those are what cause, like, earthquakes and volcanoes, right?
You got it. And out in the ocean, where these plates are pulling away from each other, that's where things get really interesting. Molten rock rises up from deep within the Earth and solidifies, and that's what creates these massive underwater mountain ranges.
Wow.
We're talking thousands of kilometers long, some of them even taller than Mount Everest.
You're kidding. Taller than Mount Everest? I had no idea. So it's like a whole nother mountain range down there.
Exactly, a hidden world.
Wow.
And then you've got the abyssal plains, these vast flat areas that make up a huge chunk of the seabed. I mean, we're talking seriously vast. Like, you could fit the entire continental United States in the abyssal plains several times over.
No way. That's absolutely mind-blowing.
It's incredible, the scale of it all.
It really is.
Yeah.
Okay, so we've got these underwater mountain ranges, vast plains.
Mm-hmm.
What about those areas closer to the continents?
Oh, you mean the continental shelf? That's that relatively shallow area that extends outward from the coastline. That's actually the part of the seabed that most people are familiar with, even if they don't realize it.
Right, like that's where we do things like fishing and offshore drilling, right?
It's a really productive zone, teeming with marine life. But then things get really dramatic when you hit the continental slope, which is the steep plunge. It's almost like a cliff, but underwater.
Oh, wow. Okay. Sounds intense. What's down there?
That's where you start heading down, down, down into the deep ocean basins towards those abyssal plains we were talking about. And down there, you've got trenches, which are the deepest parts of the ocean, some of them. Deeper than Mount Everest is tall.
Wow. It really is like a whole other world down there.
It truly is.
But what is it actually made of? Like, when I picture the seabed in my head, I usually just imagine, like, endless sand.
Yeah, that's a pretty common image. But it's way more diverse than just sand. Seabed sediments, that's the stuff that covers the ocean floor. It actually comes in a surprising variety.
Oh, okay, like what? Give me the rundown.
Well, think about it. The ocean is influenced by, well, pretty much everything that happens on land, even in space. So you've got 4 main types of sediment: terrigenous, biogenous, hydrogenous.
Whoa, hold on. Those are some big words.
We'll break them down, don't worry.
Okay.
And then my personal favorite, for the pure surprise factor, cosmogenous.
Wait, cosmogenous? As in, like, from space?
Yeah.
You're messing with me, bro.
Nope, not messing with you. It's true. But we'll get to that one a bit later. Let's break down these other ones first. Okay, so terrigenous sediment.
Terrigenous.
Yeah, it's the most straightforward one. Basically, anything that washes, blows, scrapes its way from land into the ocean.
Okay, so we're talking like sand, silt, even rocks carried by rivers, glaciers, wind, all that good stuff.
You got it. All that material eventually makes its way out to sea, settles on the seabed.
Makes sense.
And then you've got biogenous sediment.
Biogenous.
This one is formed from the remains of marine organisms.
So like seashells and stuff.
Shells are a big part of it. Think like countless tiny shells, skeletons of microscopic creatures, all accumulating over, millennia. And depending on the depth, the type of organisms, these biogenous sediments create different kinds of what scientists call oozes.
Oozes. Okay. Doesn't sound super appealing, but all right.
Maybe not, but incredibly important. For example, you've got calcareous oozes formed mostly from the calcium carbonate shells of tiny organisms called Foraminifera.
Foraminifera.
Yeah, they're single-celled creatures with these beautiful, intricate shells.
Yeah, well, I think I've seen pictures of those. They look like tiny little works of art.
Exactly. But here's the really fascinating part. These calcareous oozes are only found at certain depths. Below a certain point, the pressure, the chemistry of the deep ocean, it actually dissolves calcium carbonate.
Oh, wow. So no more pretty shells down there.
Sadly, no. The deeper you go, the more extreme the conditions become. But that's what's so cool about sediment. It acts like a historical record. Like the type of sediment can actually tell us something about the depth and the conditions of the area where it's found.
Wow, that is wild. It's like a detective story, but instead of clues, we're looking at sand and muck and who knows what else.
Exactly.
Okay, so we've got sediments from land, we've got sediments from sea creatures. What about this hydrogenous stuff? That sounds a bit more chemical.
It is. These sediments, they form from chemical reactions in the seawater itself.
Oh, interesting.
One of the most intriguing examples is manganese nodules.
Manganese nodules. Okay, those are important, right? Something to do with like valuable metals.
You got it. Imagine like potato-shaped lumps, often half buried in the sediment, packed with manganese, iron, nickel, sometimes even cobalt and copper.
Whoa, talk about buried treasure. Where do they even come from?
Well, scientists believe that these nodules precipitate out of seawater incredibly slowly over millions of years.
Mm.
And what's even cooler is that they're always found on the surface of the sediment.
Always on the surface. Why is that?
That's a question that's got researchers scratching their heads. Like it's like they're constantly being pushed up even though they're incredibly heavy. Some scientists think it might have something to do with activities of deep sea organisms or even currents within the sediment itself.
That's incredible. It's like these nodules have a life of their own down there.
Right?
Okay, I can't wait any longer. You have to tell me about this sediment from space.
All right. All right. Picture this. A meteor, maybe even just some space dust, enters the Earth's atmosphere.
Okay, got it. Fiery entrance. Happens all the time, right?
Right. Now, most of it burns up, creates those shooting stars we love, but tiny, tiny particles, they can actually survive that whole fiery descent.
No way. They make it all the way down here.
They do. Drift down, settle on the ocean surface, and over a long, long time become part of the seabed. We're talking like teeny, teeny traces, but still. Space dust mingling with Earth stuff.
That is wild. Okay, so basically the ocean floor is like this giant history book with chapters written by rivers, sea creatures, and even meteors. That's so cool. But it's not just what's in the sediment, right? Like the size of it matters too.
You are spot on. Sediment size, it's classified from like massive boulders all the way down to microscopic clay.
Wow, okay.
And that tells us about the environment where it settled. Take larger particles like gravel, sand. They usually mean high energy environment. Strong currents, maybe big waves, something that can move all that weight around.
So finding a bunch of sand would be like finding a clue that says rough seas were here. What about the opposite? Like if it's mostly fine stuff, like silt or clay?
That suggests the calmer spot, like those still, deep areas where tiny particles can slowly drift down and settle undisturbed.
Wow, it's all about reading the clues that the sediment provides.
Exactly.
This is blowing my mind. Who knew that dirt could be so fascinating? But speaking of fascinating, what about the creatures that actually live on the seabed? It's got to be a tough neighborhood, right?
It is definitely not easy street down there. We're talking extreme pressure, no sunlight. But life finds a way.
Life finds a way.
That's the amazing thing. We call all the organisms that live on, in, or near the seabed the benthos.
Benthos, got it. So what kind of creatures are we talking about? Give me some examples.
Oh, you've got everything from microscopic bacteria and those funky tube worms you see at hydrothermal vents to crustaceans, echinoderms, those are your starfish, sea urchins, even certain types of fish, specially adapted to life in the deep.
Okay, so we're not just talking about a few hardy creatures clinging to rocks down there. It's a whole ecosystem.
Yeah.
But how do they survive? I mean, it's not like there are streetlights down there. What's their energy source?
This is where things get really cool. Instead of relying on sunlight like most life on Earth, many deep-sea creatures depend on what we call marine snow.
Marine snow. Now you're really messing with me.
I promise, it's a real thing. Imagine a constant drizzle of organic matter, dead plankton, fish poop, bits of decaying seaweed, you name it, slowly sinking down from the surface.
Okay, maybe not as appealing as actual snow, but I get the idea.
Right. But for the deep-sea benthos, this snow is a feast. They've evolved to use it as their primary food source, fueling a whole web of life in the darkness.
That is incredible. So we've got this whole other world operating on a totally different system than what we're used to up here.
Hmm.
But we're not just passive observers of this world anymore, are we? Like, we're starting to make our presence known down there.
We are, both in positive and, well, not so positive ways. On the exploration front, we've made huge progress in understanding the seabed, submersibles, remotely operated vehicles, even scuba divers with specialized equipment have all given us these incredible glimpses into these amazing ecosystems.
Yeah. Those documentaries about, like, hydrothermal vents, they just blow my mind every time. It's like another planet down there.
Totally. And we can't forget about the role of satellites. You might not think of space tech as being essential for ocean exploration work, but they actually play a huge role in mapping the seabed.
Wait, really? How does that even work?
Satellites can actually measure these tiny variations in the ocean's surface height,
Oh.
which are influenced by the gravity of underwater features. Big mountains, trenches, they have a slight gravitational pull on the water above them, and satellites can detect that.
You got to be kidding me. So we're using space to map the bottom of the ocean. That's next level science.
It's pretty amazing, yeah.
Wow. But it's not all good news, is it? Like, our impact on the seabed isn't exactly stellar.
Sadly, you're right. Plastic pollution is a major, major concern. And it's not just the big stuff either. Scientists are finding microplastics, tiny, tiny bits of plastic, even in deep-sea sediment.
Seriously. So we're talking about contaminating one of the most remote environments on Earth.
It's a huge issue. A recent study estimated that there could be millions of tons of microplastics accumulating in seabed sediment, especially in the deep ocean. And because plastic takes so long to break down, it's going to be there for, well, centuries, maybe even millennia.
Millions of tons.
Yeah.
It's hard to even wrap my head around that. It's like we're treating the ocean like a giant trash can.
It's a sobering thought, for sure. And unfortunately, plastic isn't the only thing we're leaving behind. Remember those manganese nodules, the ones chock full of those valuable metals?
Oh, yeah. Buried treasure time.
Well, there's growing interest in deep-sea mining to extract those metals. Think copper, nickel, cobalt, all essential for our electronics, batteries, even renewable energy technologies.
Okay, yeah, I can definitely see the appeal. We need those metals. But I'm guessing there's a downside, right? Like, mining the seabed can't be good for the environment.
Yeah, you're right. It's a bit of a double-edged sword, isn't it?
It is.
We need these metals, but getting them, that could have a serious, serious impact on these ecosystems, especially because we're really just starting to understand them.
Yeah. And you mentioned a specific area, the Clarion-Clipperton Zone.
Yeah, Clarion-Clipperton Zone, right. It's this massive area in the Pacific, and it's estimated to hold, get this, trillions of dollars worth of these nodules, packed with metals.
Trillions. Okay. Yeah. I can see why it's a hot topic.
Okay.
But what are the environmental concerns? Like, specifically, what kind of impact are we talking about?
Well, the deep sea, especially at those depths, it's home to some seriously unique, often very fragile life forms, and they've adapted to this extreme environment over millions and millions of years.
Right.
Mining. It could, it could destroy habitats, stir up these huge sediment plumes that could suffocate filter feeders, introduce light and noise pollution in a place that's normally pitch black and silent.
Yeah. I mean, it'd be like, imagine someone just barging into your home with like a bunch of heavy machinery and just going to town.
Right. Not exactly a recipe for a happy neighborhood.
No.
And the long-term consequences,
Yeah.
honestly. We're still figuring those out, which is what makes this whole thing so tricky.
Yeah.
There's a lot at stake.
For sure. For sure. It's like you want to protect the environment, but we also rely on these resources.
Exactly.
And it's not just the deep sea mining. You mentioned dredging earlier.
Yeah. Right, dredging. That's scooping up the sand, the sediment from the seabed. And we mainly use it for things like coastal development, replenishing beaches that are eroding, even creating new land.
Wow. So even something that seems, I don't know, harmless on the surface, like fixing a beach, they can still impact the seabed.
It can. We often think of the ocean as this vast, limitless resource, but the seabed is just as sensitive to being disturbed as any environment on land. It's all interconnected.
It really is. It's
Yeah.
funny. After talking about all this, the mining, the plastic, I'm ready for something a bit more uplifting. Anything about the seabed that's a little more, I don't know, positive?
Uplifting, how about music?
Music from the seabed. You're kidding, right? Last I checked, anglerfish weren't known for their singing voices.
Not quite, but think about it. Children's songs about the bottom of the sea, stories of shipwrecks and sunken cities. The seabed has this real hold on our imagination.
That's true. Oh my gosh. I remember singing that song, There's a Hole at the Bottom of the Sea, as a kid. I never even thought about it, but it's kind of interesting how that captures, like, our curiosity about what's down there.
And shipwrecks, they're like little time capsules down there, offering these glimpses into the past. Some of them even become protected historical sites. It's like underwater museums.
That's incredible to think that something that was once, lost can become this source of knowledge, even artistic inspiration.
It really speaks to the cultural significance of the seabed, doesn't it? It's not just about the geology or the weird and wonderful life forms, but our human history, our stories, they're down there too.
Stories of exploration, trade, loss. It's a pretty powerful thought.
It is. And as we keep venturing further into the deep sea, whether it's mining, resource extraction, even just scientific exploration, we really have to be mindful of that cultural dimension. It's not just about what we're taking, but how we interact, how we respect its history, its power.
It's a delicate balance. So as we reach the end of our deep dive into this hidden world, it really makes you wonder, what's next for the seabed? We've covered so much, the potential, the threats, the need for careful consideration moving forward. Where do we go from here?
That's the million-dollar question, isn't it? There's no easy answer. It's going to require global cooperation, some really meticulous planning, and a deep, deep understanding of these complex ecosystems. We're only just starting to scratch the surface, really.
It's a journey of discovery, that's for sure. And even though we've only, well, skimmed the surface today, I think one thing's clear. The seabed is far from just this vast, empty void. It is a vibrant, dynamic world teeming with life, shaped by some incredibly powerful forces, and yeah, increasingly feeling the weight of our actions.
Well said. And as our influence grows, it's our responsibility, all of us, to consider the consequences, to strive for a future where both the seabed and humanity can thrive.
It's a future worth pondering, that's for sure. So to all our listeners, thank you for joining us for this deep dive. We'll see you next time, ready to explore another fascinating facet of our amazing world.